This question is again related to a stereochemical problem. The structure that is given is that of lactic acid. A Fischer projection structure of lactic acid is given. This is also lactic acid, this also appears to be lactic acid. These two structures are given. What is the relationship between the two compounds? Lactic acid, because of its chiral center, can exhibit optical activity. So there are two possibilities, or the two structures represent or two different representations of the same compound, or the two enantiomers. So two possibilities are there. One is the two are related as enantiomers. The second question is the two are two representations of the same compound. Two representations of the same compound. Which of the two is correct is our question now. How will you find out? There is an easy way of arriving at a solution for this. There are two structures given. Now keep one structure constant. Now try to convert the other structures by changing the groups, interchanging the groups, and make this second structure identical with the first structure. As for example, two vertical groups are in this particular structure. Consider the structure to be 1 and consider the other structure to be 2. Two groups vertically arranged are CH3 and COOH. Horizontally arranged groups are H and OH. Now in the structure 2 there is a difference. Now try to make changes, interchanges in the second compound so that it makes exactly identical with the first change. Let us now start doing it now. This CH3 exactly matches with the other CH3. Therefore, there is no need of making a change. This hydrogen in the second structure is on the right, whereas this hydrogen is on the left. Therefore, bring the hydrogen to the left so that the COOH goes to the right. So, what will be the structure that is the first interchange? CH3, don't disturb this, bring the hydrogen to this and bring the carboxy. Hydrogen is brought over here, the carboxy is brought over there. Or the two structures again is not matching. Structure 1 is not matching with one rearrangement. Now we will make one more rearrangement. CH3 is the same, this hydrogen is the same, but this COOH comes here and then the OH goes over here. Now after this is one interchange, first interchange, and this is the second interchange. After two interchanges, the two compounds look exactly identical. Therefore, by making even number of changes, the two structures become identical. Here, one change we have made here interchange, the second interchange you have made here. After you have made the second interchange, it has become exactly identical with this compound. After making two interchanges, the two structures become identical, then there are two representations of the same compound, then they are not enantiomers. So they are enantiomers means then it should be by odd number of changes, either it should be 1 or 3 or otherwise it should be 2. Now in this case, actually after making two interchanges, now we have got two structures which have become identical. Therefore, there are two representations, two different representations of the same compound.